Hi everybody, we're going to talk today about something called literal equations. Literal equations are really formulas, and we're going to rearrange those formulas. We say this different ways, but what you're going to see is an equation where instead of numbers, you're going to have a bunch of letters. But those letters are going to act just like numbers do. They could represent any real number. They act the same way that numbers do in any other equation. So I'm going to put two parallel equations here up on the screen. And the one on the left, I'm asking you to solve for x. And in the one on the right, I'm going to ask you also to solve for x. And we're going to do that in the exact same steps. If I look at the equation on the left, it says 3x minus 7 equals 14. I'm going to make a plan here as to how to solve for x. We've been doing this for a while now. What's happening to x is it's being multiplied by 3 and then subtracted by 7. So I'm going to undo those steps in reverse order. I would add the 7 to both sides. And I would get 3x equals 21. Over on the right, the idea is the same. What's happening to x is that it's being multiplied by a and then subtracted by b. So to undo those steps in reverse order, I would add b to both sides. And again, remember what that means, both sides of the equal sign, right? On the left here, I would get a times x. So same thing, that just gets carried down. On the right, I can't combine c and b. They're not like terms. So I'm just going to make that c plus b. I can't combine them together. If I could, if they were two numbers like over here, I'd add them. But they could be anything. Whatever those numbers are, I'm going to add them together. I'll represent that as c plus b. Now over here on the left, my last step would be divide by 3. And x would equal 7. Well, similarly on the right, my last step is going to be to divide by a. What am I going to divide by a? That whole thing. I'm going to divide by a. Whatever that sum was, I'll divide it by a. So my answer here is not a number. It's this combination of c's and b's and a's. So these take a little bit of getting used to because our answer is not a number. Sometimes it's just variables, and that's okay. These are called literal equations, or there's a formula, and we're rearranging that formula to make x kind of the subject of the sentence. Let's try a few more. Again, I've got parallel equations here, right? If I'm doing 4 times x equals 16, what's happening to x is being multiplied by 4, and I would divide by 4 to solve. I would get, in this case, x equals 4. Well, on the right, same idea, x is being multiplied by a, so I will divide by a to solve. And again, my answer is just a string of variables, and that's okay. b divided by a is my entire answer. That means we could put in anything for a and b. Here's how we solve for x. This is what people who use spreadsheets do. They use these formulas. They don't look exactly like this, but that's all they do. They just rearrange formulas. They rewrite equations. With these problems, you have to be told what to solve for. If I don't tell you to solve for h, you don't know what variable you're solving for. So this one says v equals LWH. That's a formula for volume. Volume is equal to length times width times height. And I want to make a plan for how to solve for that h. Well, what's happening to h? H is being multiplied by L and W. So to solve for h, I would divide. And I can divide these both at the same time. So that h is equal to V over LW. Easy, right? It was just a simple division. I want to just change that up a little bit. If I had the same equation, V equals LWH, and I asked you to solve for W, so W is in the middle here, right? It's okay to divide by L and H. Even though they're not next to each other, we can divide by L and H at the same time. So that W would equal V divided by LH. So again, even though they're not next to each other, we can divide by them at the same time, no big deal. Again, here's a couple of parallel equations. I noticed that there's a fraction here. There's a fraction on the one on the left and the one on the right. At the same time. I need to tell you on the right what we're solving for. And we'll do the same thing we're doing on the left, so we'll solve this for x. All right, so let's see. I see a fraction. I want to clear out the fraction, so I'm going to multiply both sides by 2. That's going to wipe out my fraction. 2 divided by 2 is 1. Gives me 3x plus 4 equals 9. 3x plus 4 equals 9. I'm going to do the exact same thing on the right. I'm going to multiply by p on both sides. P gets wiped out. On the right, I have VP. Whatever those numbers are, I'd multiply them together. I don't know, so I'm just going to leave them next to each other, indicating multiplication. And on the left, I have mx plus k equals VP. I'm going to go back to the left here. Where would I go from there? Well, my next step would be to subtract the 4. That would give me 3x equals 5. Subtract the k on the right, so that thing that's hanging out by itself. And again, I'm thinking about what's happening to the x. The x is being multiplied by m and then added to k, so I'll undo that minus k first. That's going to give me mx equals, now this weird looking thing, VP minus k. Again, those are just numbers. If I knew what they were, I would subtract them and I'd get another number, but I don't. This is just telling me I'm going to multiply v times p, take away k. My last step would be divide by 3. My last step is divide the whole thing by 3. X would equal, on the left, 5 over 3, and you could change that to a mixed number. On the right, divide by m, I messed up. Divide by m, don't divide by 3. M divided by m is 1, so x equals, and I get this weird string of numbers, of letters again, and that's okay. That's what our answers are going to look like, okay? It's going to look like a formula. We went from this formula to this formula by doing those inverse operations. Try a couple more. So I'm giving you the formula ax plus by equals c, and I'm going to tell you I want you to solve for x. I'm not going to do a parallel equation this time, but I'm going to ask you to think about how would you solve this equation, because really it's exactly the same thing. I'm not going to do this, but you think about the steps that you would do. To solve for x, over here the first thing I do would be subtract that 15, so I'm going to do the same thing here. Subtract whatever this is, and this thing happens to be by, and I'll subtract it on the right as well. That gives me ax, this is gone, equals this whole thing, c minus by. And again, those are just numbers. If we knew what they were, we could do the arithmetic on them, but we don't. Then the next step would be over here, once I subtracted that 15, I'd divide by the 2. Well, to get the x by itself, I'm going to divide by that a, divide everything by that a equals this. Nope, sorry. X equals, it's been a long day at school, all over a. And there's my answer, x equals that thing. These take some practice. They're not that hard once you get the hang of them, but they're weird to get used to. I'll do 2 more. We have a equals 1/2 bh. That's the equation for the area of a triangle. What I want to do is isolate that h. So again, let me think about a parallel equation. How would I solve this if I knew what those numbers are? Again, first thing I see is that fraction. I want to get rid of the fraction. I'm going to multiply both sides by 2. On the left now I have 2a. On the right of this equation, 1/2 times 2 is just 1. This is all just 1. I don't need it anymore. That leaves me with bh. And then what's happening to the h? Well, it's being multiplied by b, and the opposite of times b would be divided by b. H would equal 2 times capital A divided by b. And let's end with the hardest one of the day. We're going to solve, so here's a formula for area of a trapezoid. When we see these little things, b1 plus b2, those are called subscripts. These are not like terms. We cannot add together b1 and b2. They're considered different things, different terms. They stand for base 1 and base 2. So as I'm solving, again, I see a fraction. I want to get rid of the fraction. I'm going to multiply by 2, multiply by 2. That will give me 2a equals, and again, half of 2 is 1. I don't need that anymore. H times B1 plus B2. Let's see, I'm trying to isolate that B1. What's happening to B1? Well, it's being added to B2, and then that whole thing is being multiplied by H. So before I touch the B1 or the B2, I need to get rid of that H. Multiplied by B8 by H, the opposite of multiply by H would be divide by H. That gives me 2A over H equals B1 plus B2. And now I'm winding down. I want to isolate that B1, and the way I'm going to do that is by subtracting out the B2. And again, this is an ugly answer. B1 is equal to a big giant thing here, 2A divided by H minus B2. That's my answer. Again, these are kind of ugly, but they take some practice, but we can get used to them. All right, so I'm going to stop here and check your homework for tonight.